In a chemical reaction, a reactant reacts with a reagent under certain reaction condition to yield a product and byproduct. Let's see how to represent this equation in a symbolic form. We must bear in mind that the two sides of the equation must be numerically balanced. Let's assume we have a few pairs of wheels that will fit various different types of vehicle. Let us represent a pair of wheels as W2. How can we assemble wheels on a bike body B, a two-wheeler, a car body C, a four-wheeler, a tricycle body, a three-wheeler A, truck body T, a six-wheeler and a trolley with one wheel? With a pair of wheels, we can have a bike. With two pairs of wheels, we can have a car. With three pairs of wheels, we can have a truck. How can you assemble pairs of wheels to set up a three-wheeler? With three pairs of wheels, we can have two tricycles. How can you assemble a trolley R with a single wheel? With a pair of wheels, we can have two trolleys. We can balance chemical reactions in the same way. This is an example of a word equation. In order to handle the number of moles of reactants and products numerically, it would be convenient to represent them in a symbolic equation. How can we balance reactants and products numerically? Let's consider the wheel analogy. We were able to make an equation to represent the wheel requirements for single-wheel trolleys. It is after a similar pattern that when we combine 2 moles sodium with 1 mole chlorine molecule, we get 2 moles sodium chloride. What are the steps involved in balancing a chemical equation mentioned in this reaction? Write the word equation. Write the symbol equation. Write down the number of atoms present on each side of the arrow. The atoms are not balanced in this equation. Start balancing from the element with the greater number of atoms. Do not give priority to the atom found in more than one compound on either side of the arrow. For example, since oxygen is present in 2 compounds on the right-hand side, we should not give priority to the oxygen atom when balancing. Balance the hydrogen atoms by multiplying by 2 on the right-hand side. Write out the partially balanced equation. Write down the number of atoms present on both sides of the arrow of the revised equation. Again, check whether all the atoms are balanced. Balance the atoms of the remaining elements, here oxygen. Write down the balanced equation. Mention the states of reactants and products within brackets. The subscripts G, L, S represent gas, liquid, and solid, respectively. Finally, write the reaction condition above the arrow mark. Here the reaction needs heating. This is indicated by a small triangle. Let us consider another example. Tabulate the number of atoms of each element present in the equation. Hydrogen and sulfur are balanced, but there are 2 oxygen atoms on the left-hand side and 3 on the right-hand side in 2 different compounds. However, the oxygen present on the right-hand side is distributed in 2 different compounds. So, we can avoid adjusting the right-hand side. We can equalize the number of oxygen atoms by multiplying the coefficient of oxygen on the right-hand side by a fraction, 3/2. Let us write down the molar coefficient in the equation. To obtain a whole number, we can multiply the whole of the equation by 2. Now, we have the balanced equation.